Welcome to again this very important session. It's a free training and live streaming. Thank you so much for joining on time. And today we are going to learn another important topic as a part of this series. The topic is hypothesis testing. Due to time constraint, it's not possible to cover entire hypothesis testing because it is a very important and huge topic to learn. And it also consists of the too many types, too many concepts into it. But I will give a fair idea about it. That means I will help you to understand what is this hypothesis testing and what are the various types of it, how we can learn that. And if you want to implement that or if you want to perform that hypothesis testing into the real life, then what is the methodology that we are going to follow? Okay. So just wait for a minute and then we can start. Great. So if you're having any questions, any comments at any point of time, and all these as and when I will get the time, right? Great. Welcome to everyone. Welcome to this free live training to learn one of the important topic from the Lean Six Sigma as well as from the statistics. Thank you so much for joining on time, and I really appreciate that you have registered for this event and you are attending it live. Great. If you are having any expectations or anything about this training, you can put that into the chat box. Now let's start. Deeptendu, thank you so much. Your message. Thank you so much. Glad to see you. Great. So let me start with the presentation and let me help you to understand, okay, what are the topics that we are going to learn today? Okay, so let me share the presentation. Can you see my screen? Great, thank you. Okay, so the today's topic is, as you can see here, how to learn hypothesis testing effectively and practically. Yes, you read it very right, practically. That means I'm going to take the one example and I'm going to perform the one hypothesis testing in front of you using the Microsoft Excel and also using the Minitab, right? So we are also going to learn one of the hypothesis testing practically. And the word, if you are looking for the effectively, I'm also going to explain what is the system or what is the approach that we need to follow so that we can learn this hypothesis testing effectively, right? Now, let's understand what is the approach that we are going to follow. This consists of six important sections of the today's live training. The first one is we are going to understand what is hypothesis testing. Then we will understand why hypothesis testing is important with the help of example. Then we will go to the second point, which is what are the various types of hypothesis testing depending on the type of data or the metric that we are going to compare. I will also explain what is a general procedure for conducting or for performing this hypothesis testing. And after that, I will explain with the help of practical example these steps. In fifth step, I'm going to explain if you want to learn entire hypothesis testing, then how we can learn that with the lifetime mentoring support and lifetime access to the content. And into the last section, I will answer all your questions related to this hypothesis testing as well as Lean Six Sigma. Yes, of course, anything related to the career growth as well. Okay, so let's go into the part. Now, before that, let's see if you're having any questions, comments. Thank you so much, Mohan. Glad to see you. Thank you so much for your valuable comments. Great. So let me get that into this. Yes. So let's go to the first topic, right? So the first topic, first section of the today's is what is the hypothesis testing? So let's go into the detail of it. Now, let's make it simple. I'm not going to explain the critical statistical concepts here because the intent is to give the clarity, right? So here I'm going to explain as a part of system and as a part of methodology what it is, right? So hypothesis testing is the statistical technique. Why it is called as a statistical technique? Because we are going to use the database approach in this technique, and by using database approach, it will help us to understand which decision is correct or which option is correct, right? So it is a statistical techniques used to test your assumptions based on data. That means sometimes we are having some assumptions. Like for example, we are talking about we are having the more problem related to our process on every Friday. That may be our assumptions, right? Or that may be our gut feeling. If you want to test that, then hypothesis testing is going to help us. Second, select the correct option out of many. That means, let's say we are having the three suppliers. Out of that three suppliers, we need to select the which one is the best. Or let's say we are having the three machines, which machine performance is better. If you want to select the best option out of many, then again, we are going to use this hypothesis testing. Validate the results based on data. That means, let's say we are identify what is the root cause of the one of the problem, and we want to identify or we want to validate that with the help of data, whether that root cause is going to kill the occurrence of the problem. Now, how to do that? For that purpose, again, we are going to use the hypothesis testing. Compare samples or populations. Again, if you want to compare the many things, let's say if you are going to compare two samples, whether it is dependent or independent, or when we are going to compare the three samples or more than three samples, in that case, we are going to use this hypothesis testing. So if you see, the hypothesis testing is a very important tool that we are going to use at every stage of the implementation. So whether we are talking about the Six Sigma, whether we are talking about any other approach, but if you want to validate our results, or if you want to select the correct decision out of many, then hypothesis testing is a very important tool. Now, if you want to summarize everything in short, what is hypothesis testing? It is a statistical technique that is used to take a correct decision in any situation based on data. Based on data, that's a keyword here. So we are going to use the statistics to identify which option is correct, which results are more appropriate, right? So this is the first section. We have understood that what is hypothesis testing. Is this clear to you? Do you have any questions on this? Thanks for organizing this session. You're welcome, Biggie. Thank you so much for your comments. Yes, so this is the hypothesis testing. Okay, let's understand. What is important here? It is a statistical technique used to take a correct decision in any situations, right? Now, let's go into the detail of it and let's understand why we need to implement or why we need to use this hypothesis testing. So I'm going to share you the small presentation. With the help of that, you will get idea about it, why it is important. Okay, can you see my screen here? This is why I put this testing. You can see here picture. It's the most popular picture that we can see, right? Because recently we have gone through this phase, COVID-19, and the common question comes in our mind. Let's say we are having the three vaccines. If we talk typically about the India, we are having the Covaxin, we are having the Covishield and Sputnik. And the question is always that, okay, out of these three, which one is better? And for which vaccine I should choose, right? For which vaccine I should go. So that's the common question comes in our mind. Now, if you want to identify that, hypothesis testing is going to help us because we can see here are three options, and out of that three, we are going to identify which one is better. Now, if you take typical case of a COVID-19, it's very complicated because we cannot predict just by using or by calculating the vaccine efficiency because it again consists of the multiple factors like the medical history of the patient, its age, and multiple factors like region as well. So if you want to identify that, we also need to consider that factors. Now let's come back to the point we are discussing about why hypothesis testing. So let's go into the detail of it. If you see the real world, in real situation, if you are going to take any decision, how we take the decisions? Let's don't talk about the hypothesis testing. Let's talk about the general situations. So there are four conditions by which we take the actions. The first one is we take the decision by our judgment, right? In some cases, we take the decision based on assumptions, and many times these assumptions can be wrong. Sometimes this decision is driven by the position in the organization. That means the higher authority person, what is his or her thinking, we are going to take the decision in that direction. And the last one is we can take the decision based on our experience, gut feeling, what we feel, whether we are feeling it's a good, bad, or we are neutral. Based on that, we are going to take the decisions. But if you see, just imagine that if you are going to take the decision based on the influence by others or by judgment, by our experience, are we going to take the right decisions? Many times, no, right? Many times, sometimes, okay, that decision may be correct, but many times that decision is going to be wrong. What is the impact if our decision is wrong? Let's go into the detail of it. If you are going to monitor the process and if you are going to work on the process, so there is always probability that you can catch the good process on a bad day. That means process is good, but because of wrong sampling or because of the random sampling, we can say that the process is bad. And that can also happen vice versa. There is a bad process, but whatever the sample that you have selected, that sample is good. And you are saying that process is good. But in either situation, we can see the decision is wrong, right? We say we made an improvement in the process sometimes, but the result is just a function of sampling. But how we can say whether it is not a function of sampling and our decision is correct? For that purpose, we need to use the hypothesis testing. Let's take another example. If we talk about the hypothesis testing, making accurate decision is very critical for any organization. And why it is important to have the great success rate, to have the desired results. Statistical hypothesis testing is a very useful and data-based approach to make correct decision in critical situations. Let's say if you are going to purchase one equipment, and that equipment you are saying that based on your experience or based on your judgment that equipment is very good. If you make a judgment and purchase a new expensive equipment to improve process performance, but if you execute that into the real life onto your field and you found that it is not significantly better than the current equipment. Yes, it is somewhat better, but it's not significantly better. Then what is going to happen? It leads to significant loss to the organization, right? That's why taking the correct decision is very important. If you see this person, you might heard the name of that person, Herbert George, H.G. Wells. He was the person who was involved in the time machine, the War of the Worlds, the Invisible Man, the Island of Dr. Moreau. So this person is also called as a father of science fiction. And look at his sentence. That sentence is we can say the 1866, or we can say the early 19th. The statement is statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write. And that is today, right? We can see everything is based on the data. Every industry, every organization is using the artificial intelligence, machine learning, big data, Six Sigma, all these data-based approaches. Every industry is using data science today. This is because the statistical thinking is very critical, and this is becoming again more equivalent to ability to read and write. That means you must have these two important skill sets: the ability to collect the data effectively and analyze it accurately. So these are the two important skill sets that are emerging out as a more important skill sets. If you go into the more detail, let's say if you want to solve any practical problem, so I'm going to understand, I'm going to explain you how this work, right? So what is the approach that we are going to use into the Six Sigma? Any practical problem that we are going to define in detail. That means we are going to identify what is a practical problem and we are going to convert that practical problem into statistical problem. So this is the first step. And as soon as we convert this problem into the statistic or statistical problem, we can solve it. Why? Because we are having the various statistical tools, basic as well as advanced. And by using these statistical tools, we are going to identify the statistical solution of it. That is the power of statistical tools. And as soon as we convert into the statistical solutions, it can be reversed into the practical solution. So this is the approach that we are using into the Six Sigma implementation. And the same approach we are using into the hypothesis testing. We are going to identify what is the actual practical problem and then we are going to quantify it. Then we are identifying the solution of it based on the hypothesis testing, various tests that we are going to use. And after that, we are having the practical conclusion. That's why it's very important to understand hypothesis testing. Now, I'm sure from this presentation, you have got the idea about why it is important, right? So let me see, there are comments. Okay, thank you so much. Right, so into the first section, we had seen what is hypothesis testing and why it is important, why we should learn this hypothesis testing, and if you are going to learn that, how it is going to help us. That is the important thing that we had seen. Now let's go to the point number 2, that is what are the various types of hypothesis testing. So let me share that. Again, as I had already explained to you, this is having the huge application into the real life, and that's why too many types of it. Now, depending on the type of data mainly and the statistical metric that we are going to compare, there are two important types. The first one is called as a parametric test. In that, we are going to compare the mean, we are going to compare the variances, we are going to compare the standard deviation, we are going to compare the proportions, and in other case, we are going to compare the medians. That is called as non-parametric test. Parametric test are having the more power compared to the non-parametric test. Again, I don't want to make it complicated, but let's understand here. There are mainly two types of hypothesis testing. One is parametric test and there is a non-parametric test. Parametric test, again, we can divide that into three categories. And similarly, non-parametric test also we can divide that into three categories, like one sample test, two sample test, and more than two sample tests. Let's go into the detail of parametric test first. When we are going to compare one sample with respect to some reference value, then we are using one sample test. Let me repeat that. That means we are having one sample and we want to compare that sample with respect to some standard value, right? In that case, we are going to use the one sample test. Now, depending on which metric that we are going to compare, there are various types of hypothesis testing. Like if you are going to compare the mean of the sample with respect to some reference value, we are going to use the one sample t-test. If you are going to use the reference standard deviation with respect to the sample standard deviation, if you want to compare, then we are going to use the one sample standard deviation. If you want to compare the variance, one variance test. If you want to compare the percentage defective in sample with respect to some reference proportion value, then we are going to use the one sample percentage defective or one proportion test. Or we can also use the chi-square goodness of fit test. This chi-square goodness of fit test is used when we are having the many proportions into the different categories. So we can see here, depending on the metric that we are going to compare, under one sample test, again, we are having the multiple types, right? In similar fashion, if you are having the two samples to compare, let's say if you are going to compare the means of two samples, then we are having the two sample t-test. If you want to compare the two samples, but the data is dependent, like before and after, right? In that case, we are going to use the pay t-test. If you want to compare the two sample standard deviations, two sample standard deviation test is going to be used. Or let's say if you are going to use the two proportions, then two proportion test is going to be used. So depending on which metric or which statistic that we are going to compare, there are again different types under two sample test as well. Now, if you are having the more than two samples, let's say 3, 4, 5, 6, or 10 or 15 samples, how we can compare that? For that purpose also, advanced parametric tests are available. Like if you want to compare the means of more than two samples, we are going to use the one-way ANOVA. We can use the standard deviation test or test for equal variances if you are going to compare the variances of more than two samples. Chi-square percentage of defective test and chi-square test for association if you want to compare the proportions for more than two samples, right? So this is just an introduction. We can see based on how many samples that we are going to compare and which metric that we are going to compare, there are various types of parametric tests. Now let's go into the detail of non-parametric test. Non-parametric test also having the multiple types. Like in one sample test, there are two main types are there. One is called as a one sample sign test and one sample Wilcoxon test. Now these are depending on whether your distribution is symmetric or not. If your distribution is symmetric, that means if you cut that into the half, if left side is equal to the right side, we can say it's symmetric. In that case, we are going to use the Wilcoxon test. And if it is not, we are going to use the one sample sign test. Yes, I can understand that if you are going to learn this hypothesis testing first time, yes, it might be difficult to understand you, but if you are going to apply the logic, please believe me, it's a very simple topic because it is based on the logic. Now, this non-parametric test that I'm going to explain, in that case, we are going to use the median. We are going to compare the median of two samples, or we are going to compare the sample median with respect to some reference median. Two sample test, there is a Mann-Whitney test. That means we are going to compare the medians of two samples. If you are going to compare the median of more than two samples, there are again two types. One is Kruskal-Wallis and Moore's median. These are again depending on whether you are having the similar shape distributions or not. And the last type is other non-parametric. That means these are the extensions of the non-parametric test. It's called as a Friedman test and Run's test. Friedman test is used to median treatment, whether the median treatment effect differs in randomized block design. And Run's test is used to check whether the data is in random order or not, right? It might be difficult to you to understand at a first glance, but let's understand here. What is the main topic or main learning you must have from this section is depending on the metric that you are going to compare and how many samples that you are going to compare, there are various types of hypothesis testing. Is this clear to you up to this point? Do you have any questions? Screen is not visible. Okay. Can you see it now? Okay. Okay. Thank you so much. Great. Now let's go to the third part, which is if you want to implement or if you want to perform the hypothesis testing into the real life, we need to follow some procedure. So what is that procedure? Let's go into the detail of it. And after that, I will explain with the help of example how we can perform that into the Excel as well as into the Minitab. So let's understand general procedure to conduct hypothesis testing. You can also make a note of it. It's a very important, and you will get everything in structure and in a systematic manner where you will didn't get this anywhere. So it's very important to understand this. So there are 5 important steps. The first one is specify the hypothesis. So we need to understand what is the practical problem, and we need to formulate 2 important hypotheses here. One is called as a null hypothesis and alternative hypothesis. Of course, we need to go into the detail of it to understand what is a null hypothesis and alternative hypothesis. I will explain in short once we are going for one of the example. But this is the first step. We need to specify what is the hypothesis. In that, we need to mention what is a null and what is alternative hypothesis. Second step, we need to select the significance level. This is also called as alpha. So every time when we perform the hypothesis testing, we can see we are having the statement that the alpha value is less than significant, or p value is less than the significance level or not. So here we are going to compare that p value with respect to the significance level. Now, if you take the general value for this significance level, it is 0.05. This is a default value. And that is always talking about the 95% of confidence level that we are going to use the rejection of null hypothesis. Okay, I am not going to the detail of it. Just understand the procedure. Specify the hypothesis, what is a null hypothesis and what is alternative hypothesis. Then select the significance level. This is alpha. General value is default value is 0.05. In third step, determine the power and sample size for the test. This is because as we are going to increase the sample size, the power of the test is going to be increased. As we are going to increase the sample size, we are going to detect the smallest difference between the values. That's why it's very important to understand for particular power, what would be our sample size. Let's say if you are going for the 95% of the power, then what should be our sample size for performing particular hypothesis testing. So that is clearly mentioned into the each of the data consideration, and also you can calculate from the Minitab or Excel, or also by using the formula what should be the sample size for typical power. Okay, so this is the third step. Just understand the steps. Specify the hypothesis, select the significance level, by default it is 0.05, determine the power and sample size. In fourth step, once we complete all these three steps, then collect the data. When you are going to collect the data, please make a precaution that whatever the measurement system that you are going to use to collect that data is capable, and we need to consider data requirements. What are that data requirements? I'm also explain in detail for one of the example that I'm going to explain. Okay. And the last part is compare the test statistic with respect to the p-value. If the p-value is less than the significance level, that means we are going to reject the null hypothesis. And if this p-value is greater than significance level, we are failed to reject the null hypothesis. That means which decision that we are going to take, that is, we have mentioned into the null hypothesis and alternative hypothesis. These are exactly reverse statements, and based on this value, we are going with the null hypothesis or we are going with the alternative hypothesis, right? So with which statement we are going to select, or on which statement we are going to believe, that will be depend on this p-value with respect to the significance level. So these are the five important steps that we need to follow during the application or while we are going to perform this hypothesis testing into the real life. Okay, is this clear? Any questions till the point? Okay, now let's go to the example part. Okay, there is a question. Isn't it assumed that once you specify your hypothesis, then alternative would be the opposite? Yes, that would be. I will explain that. As we are going to take the one example, I will explain what is a null hypothesis and alternative hypothesis in short. Though there are too many concepts in the hypothesis, like the next question is, what is a p-value, right? P-value is a probability value, and that is talking about what is the evidence, what is our confidence level to reject the null hypothesis. So if the p-value is lower, then we are going to reject the null hypothesis. So that's the relationship. Now, if you want to go into the detail of statistics, I think it will take more time. And if you see the agenda, that I'm going to explain what is a methodology. Okay, maybe sometime later I will explain what is a p-value and how we can calculate that as well. Okay, thank you so much. Now let's go into the detail of this example. Let me share the screen and let's talk about that example. Perform hypothesis testing with example. Just a minute, let me share the screen. Okay, I think I have explained that. Yes. Let's take one of the hypothesis testing. I'm taking the test that you can easily understand and you can relate whatever the things I have explained. The test is two sample t-test. And if you recall, whatever I mentioned during the selection of the hypothesis testing or various types of the hypothesis testing, two sample t-test is used when we are going to compare two population mean with each other. That means we are having two samples, and the intent is to check whether the means of these two samples are significantly different from one another or not. For that purpose, we are going to use the two sample t-test. Now, when we are going to perform this two sample t-test, there are two main types. One is we can assume the variances are equal, and or we cannot assume the variances are equal. Let's don't go into that part, and let's go with the second option, that not assume that variances are equal. Okay, so we are not interested into identifying the variances at this point of time. We are interested in means, so we will go just with the comparison of means. Now, Let's understand what is the null hypothesis in these situations. When we are going to perform the two sample t-test, the null hypothesis, it is denoted by H0, and the statement is H0 colon mu1 is equal to mu2. This mu1 and mu2 are nothing but the means of the two samples. If we go into the detail of it, we can understand or we can explain this as H0 colon mu1 is equal to mu2. That means the population means mu1 and mu2 are equal. So when we are stating the null hypothesis, this null hypothesis always in equality. Always in equality. That means we are explaining null hypothesis with respect to equal sign, right? Here, mu1 is equal to mu2. And if you talk about the alternative hypothesis, that is reverse of that. That means we are going to take the statement which is opposite of that. Now, opposite statement of mu1 is equal to mu2 can be three statements. What are they? Like, we can have the statement mu1 is not equal to mu2. That means the population means mu1 and mu2 are not equal. What is our area of interest? We just want to compare that they are not equal, or we want to prove mu1 is greater than mu2, or mu1 is less than mu2. So what is our area of interest? Whether it is mu1 not equal to mu2 or greater than mu2 or less than mu2. So based on that, we can select the alternative hypothesis, right? At any point of time, we are going to select one alternative hypothesis. If you are selecting is not equal to, this is called as two-sided hypothesis. And when we are going to use the greater than or less than, it is called as one-sided hypothesis. After that, we need to calculate the test statistics. This test statistics, there are various formulas for each of the hypothesis testing to calculate this. For example, in two sample t-test, as we are going to use the t-statistics, so that can be calculated by using this formula. X1 bar minus X2 bar, these are the means of each of the samples, divided by full standard deviation into square root of 1 upon n1 plus 1 upon n2. This n1 and n2 are nothing but the sample sizes. And this full standard deviation is calculated by considering both standard deviation for each of the sample and what is the sample size, right? So these are just understand here. There are different test statistics for each of the hypothesis testing, and we can calculate that by using related formula for test statistics, right? So just understand here, we are going to define what is a null hypothesis, alternative hypothesis, and what are the formulas to calculate the test statistics. Now, what are the data considerations? For two sample t-test, we need to understand here, data must be continuous. Continuous means the data can be expressed in terms of fractions, like 12.4, 13.5, something like that. The data must be continuous. That's the first requirement. Second, the sample data should not be severely skewed and sample size should be greater than 20. Now, from where the sample size greater than 20 has come, this comes from the power. As we are going to have the power more than 95%, we are talking about the sample size of at least 20, right? Third, the sample data should be selected randomly. That means it should not be only some specific data. It is a randomly selected data. Each observation should be independent. The data should not be like before and after. They are having the same characteristics. And we need to determine an appropriate sample size. So we have already talked about it should be greater than 20. So these are the 5 data requirements for the two sample t-tests. That means at any point of time when you are going to perform these two sample t-tests, that means we are having two samples, and if you have to compare the means of these two samples, we need to check this. Whether the data is continuous, yes. Whether the sample size is more than 20, yes. Whether the data is collected randomly, yes. The data should not be dependent, yes. And whether we are having the sample size more than 20, yes. Then we can go for performing this two sample t-test. So these are the basic things, right? If you see the procedure, general procedure that I have explained to perform the hypothesis testing, we have seen that we are going to formulate the hypothesis, we are going to select the significance level, then we need to follow these data considerations. And now let's go into the example part. This is an example. We are going to compare two samples. We are going to compare two hospitals here. A healthcare consultant wants to compare the patient satisfaction ratings of two hospitals. So this is the hospital A and this is the hospital B. And the consultant wants to compare the satisfaction ratings of 20 patients from each of these. That means for that purpose, the healthcare consultant takes the 20 patients from hospital A and 20 patients from the hospital B, and he wants to compare these ratings so that he can say what is the average rating of both of these hospitals and whether they are significantly different or not. Based on that, he can say whether hospital A is better or B is better. The consultant performs two sample t-tests to determine whether there is a difference in patient ratings between the hospitals, right? So let's perform that first into the Microsoft Excel. I will show you the data, how to perform that, how to represent that graphically, and then I will show you how we can perform that into the Minitab. Okay? So are you ready for that? Have you understood this example? Do you have any questions? Any questions? Okay, great. So let me share you the Excel. Can you see my screen? Okay, let me delete this first. It's already performed. Okay. So these are the ratings. Ratings for the hospital A. We are having the 20 samples. We can see here, count 20. And there are 20 ratings for the hospital B, right? To see that at a glance, I have just inserted that here. So we can see here, there is a hospital A rating and hospital B rating, right? Now, as we had seen, we want to compare whether hospital A and hospital B are having the different ratings or not. For that purpose, we are going to use the two sample t-test. Now, how to perform that in Excel? To perform that in Excel, we must activate this data analysis option, which is present under the data tab. Now, let me show you that first. We need to go to the data tab. After that, we need to go to the data analysis. Click on that. As soon as you click on the data analysis, we can see various data analysis tool options are opening. If we are interested here, t-test. So we need to select here. We can see there are three options are there. Paired to sample means, is our data paired? Paired means our data is collected into before and after format. No, so we are not going to use this option. So let's go for the other t-test options. There are two t-test options. Assuming equal variance, assuming unequal variances. So before assuming equal variances, we need to perform the variances test and we need to check whether the variances are equal or not. So we are not selecting this. We are just going with two sample t-test using unequal variances. So select this option and click OK. What is the option that we have selected? T-test two sample assuming unequal variances and then click OK. After that, we need to mention what is the variable 1 range and what is the variable 2 range, right? So we can click on this vertical arrow and mention that hospital A rating as our first variable. Make a enter. Then variable 2 is our hospital B rating. We can select that and make a enter. So we have provided the input data. What is the variable 1 range and what is the variable 2 range. Then we need to mention hypothesized mean difference. Now, if you understand what is our null hypothesis here, mu1 is equal to mu2. That means mean of the hospital A rating is equal to mean of the hospital B rating. That means both are equal. And if you are going to calculate the difference, if both are equal, that means the difference is 0. Both are equal means both the difference is 0. mu1 minus mu2 is equal to 0. Have you selected the labels? Yes, because we have selected from the row number 1. So we can check this. See here, the alpha value by default it is 0.05 because we are using 95% of the power. That's why the significance level here is 0.05. Okay, now let's go into the output options. We are having the multiple output options. output range into the same worksheet, into the another worksheet, or into the new worksheet plan, right? So we just select this output range so that we can have everything into the same worksheet. Click anywhere into this worksheet. Let's say we click here, make enter. Once you selected that option, the cell for the output, then click OK. Here is the output. So we got the output for this 2 sample t-test. We can see here the hospital A rating is 80.3 and the hospital B rating is 59.3. So we can say the hospital B rating is much lower compared to the hospital A rating, right? But this is just a comparison, but whether that is significantly different or not, for that purpose, we need to look for the p-value. Now let me make everything as a same digit so that we can compare easily, right? Here it is. Now look at the variance. Variance for the case of hospital A is 67, so we can say it's lower, but hospital B is 154. So we can also see the variance is also very high. So that means difference between the ratings is also very high for the hospital B rating. Observations are 20 for both of these. We have selected the hypothesis difference is 0. Degrees of freedom are, okay, let's go into the detail after some time into that. Now let's understand here. If we check here, the p-value for the 210, because we are looking for whether these two are significantly different from one another or not, right? Now, if you see here, the p-value is coming at 0.00. That is less than the significance level which we have selected 0.05, right? So we are going to reject the null hypothesis. What is the null hypothesis? Both are equal. So we are going to reject that. That means both are not equal. One of the hospital is having the better rating compared to other hospital. Now, which is this hospital? Now, let's go into the mean and we can identify that hospital A is significantly better compared to the hospital B because of higher rating, which is 80.3, right? So with the help of this hypothesis testing, we can take the decisions whether we should go for the hospital A or hospital B, right? Now, how we can represent that in the form of graphical format. Okay, so there is also the option called as a box plot. So how to do that? Let me show you that. Select this data, hospital A rating and hospital B rating, then go to the insert tab. After that, we need to select this histogram option, and if you click on that, we can select here box and whisker, right? Just click on that and here it is. We are getting the box plot here. If I add the legend here, remove this. Yes, we can see here hospital A rating and hospital B rating. Just graphically, by comparison, graphically also we can see hospital A is better than hospital B, right? Now, this also can be seen once you plot this graph and we can say hospital A is better than hospital B, but sometimes it's very important to understand whether it is significantly different or not. Now, what is the meaning of this significantly different? Okay, so that can be the question in your mind. So let me explain you what is the significantly different and why the word is coming. And after that, I will explain you how to perform this hypothesis testing to sample t-test into the Minitab, right? So this is I have explained in Microsoft Excel. So let me first explain you what is this significantly different, and after that go to the Minitab. Is this example helpful to you? Okay, I've just taken the simple example that everyone can understand. For automotive, yes, there are also examples are also there into the my program. You can check that, but I've just taken the simple example. So let me share you the screen. This video is about learning of terms and concepts used in hypothesis testing. Let us say that average marks in science of class 9 students of ABC school are 85. On the other hand, if we randomly select 30 students and calculate their average score, their average comes to be 95. What can be concluded from this experiment? It's simple. There are two conclusions. One, these 30 students are different from ABC school's class 9 students. Hence, their average score is different from the population, that is, all ABC school class 9 students. Or in simple words, these are two different populations. And 2, there is no difference at all. The result is due to random chance only. That is, we found the average value of 85. It could have been higher or lower than 85 since there are students having average score less or more than 85. Now, how should we decide which explanation is correct? There are various methods to help you to decide this. Here are some options. 1. Increase sample size. 2. Test for other samples. And 3. Calculate random chance probability. The first two methods require more time and budget, hence aren't desirable when time or budget are constraints. So in such a cases, a convenient method is to calculate the random chance probability for that sample. That is, what is the probability that sample would have the average score of 85. It will help you to draw a conclusion from the given two hypotheses given above. To do this, hypothesis testing comes in picture. Before to start learning of hypothesis testing, let's understand some basic terms in it to make understanding of hypothesis testing much easier. Right? So we had seen that what's the difference? What's the meaning of significantly different? Sometimes we can see yes, it's a difference is there, but whether that difference is significant or not, for that purpose we need to check this hypothesis testing because we are going to take the decision strongly, right? Which one is better and which one is not better. For that purpose, this is very critical. Okay, now let's perform that into the Minitab, this two sample t-test. Okay, so can you see my screen, the Minitab screen? Yes, I've explained you how to perform that in Microsoft Excel by using the data analysis tab, also by using the graphical tools. Okay, so let's understand here. As we are going to use these two sample, as we are going to compare the means of two samples, that is that we are going to use the two sample t-test. So go to the basic statistics, and after that we need to select this option, two sample t-test. You can read there. Determine whether the mean differs significantly between two groups. So select this option. After that, there are three options we can get. We can have both samples are in the one column or each sample in its own column, or we can have the summarized data. In this case, we are having both sample are in the one column, so we can select this. Now, what is the sample? Sample is the rating. So we need to select this rating option, and sample IDs are in the hospital. So these ratings are indicating the continuous data and IDs are indicating the data for which variable that you have collected. Okay. After that, we need to mention what are the options. Here we can mention what is the confidence level, 95%, which is available there. Hypothesis difference is 0. And after that, we can select which alternative hypothesis we are interested, whether it's not equal to or less than or greater than. We can select it's not equal to. Assume equal variances, we can select if you're assuming that variances are equal or not. So let's keep it as a blank and click OK. In graphs, we can select the box plot to also understand the results into the graphical format and then click OK. Click OK. So we'll be getting the results both in statistical format and again in graphical format. We can see here the rating for the hospital A is 80.3 for 20 samples and for B it's 59.3 for 20 samples. If you see the 95% confidence interval for the differences, that is ranging from 14.22 to 27.78. and the minimum, the average difference between these two is 21, and the p-value is 0.000, which is less than 0.05. So we are going to reject the null hypothesis. We can also look at the box plot and we can see the rating for the hospital A and hospital B. If we can see here, what is the average rating, that also we can see here. The average rating for the hospital A is 80.3 and for the hospital B is 59.3. That also we can see. Also we can see the variance, and there is a star that are indicating outliers. So there is a huge variation into the hospital B rating as well, right? So again, we can see, we can also draw the same conclusion by using the Minitab as well. So there are various options to perform this. We can also perform that into the Sigma Excel, but due to time constraint, I'm not covering that. I have explained in both Excel as well as in Minitab, right? I'm sure with the help of this example, you got the complete clarity that, okay, what is hypothesis testing, why it is important, what are the general steps that we need to follow, and how we can perform that into the Excel as well as in Minitab, right? Now let's go to the next point, which is about how we can learn the entire hypothesis testing with the help of examples and mentoring support. So if you want to learn that in detail, so for that purpose, we can, let me show you the screen. If you want to learn entire this hypothesis testing, right? So I'm talking about both of these, parametric testing as well as non-parametric testing, then we need to simply visit here, vijaysabe.co/hypothesis. So once you visit there, you will get the entire hypothesis testing that inclusive of the parametric testing, non-parametric testing, and how we can perform that into the Excel as well as into the Minitab, right? So everything you will get here. So this is all about the points that planned for today. And the last topic is about your questions. Now, if you're having any questions, please ask that, and I'm ready to answer all that questions. Thank you so much for your valuable time, and really appreciate that you are here till the end of this session, and I'm sure that you got the great value from it. Thank you so much. Let's see you in the another free training, and please take care.